Well, friends, welcome back. Today I am to discuss with you linear programming problems (LPP). Very important technique of operation research. Linear programming problems is a vast subject, vast topic. We have to understand it thoroughly and clearly. Before I take any practical example, I wanted to tell you certain basic things which you have to remember. Only then you can solve any exercise. As I have mentioned, Simplex Method. So let me tell you some basic things of Simplex Method. So the word is in LPP, the word is linear. This is very important. Linear means direct relationship, positive and direct relationship in the objective as well as in the constraints. So let me tell you this Simplex Method, a linear programming format, or you can say the basically which you are to follow while you are going to solve any exercise or any numerical. So first point is in this linear programming problem, sometimes a statement is given and sometimes equations are given. So basically first point which we are to remember to check the objective function. To check the objective function, here objective is very important. Basically, everywhere we are having two objectives. One is maximization, another is minimization. So there are two types of objectives: maximization objective and another is minimization objectives. Minimization objectives. What we are to maximize? Everybody in any business, commerce, business management, industries, everybody, we common man, what we want to maximize? We always want to maximize our output, sale, profit, revenue, revenue. So these things are to be maximized. Say efficiency also we want to maximize, and we always want to minimize our cost, time, distance, wastage. These two things are very important in our Simplex method or linear programming problems. And in linear programming problems, the objective function is denoted by Z. Actually, this is Z. Z is the objective function, and this objective function will be either maximize or minimize. This you have to check first, or you have to specify it whether it is maximize or minimize. And this objective function is expressed in form of equations c1x1, c2x2, so on, cn xn, where Ci means C1, C2, C3 are the coefficients of variables, and Xi are the variables. Variable means which varies, which we have to calculate. So this z is the first thing, is the objective function. So before doing any numerical, solving any numerical, you have to be very particular to note whether it is maximization or minimization. Why? This I will explain later on. This is the first point. Second point is constraints. Constraints, or you can say limitations. Whether we want to maximize or minimize our profit, there are number of restrictions, there are number of constraints or limitations, and these limitations or restrictions are in the form of resources. Manpower is the resources, capital is the resources, machines, working hours are the resources. So limitations are there. So these limitations are expressed in forms of equations. Say a11x1, a12x2 plus a13x3. Either it is less than or equal to, or greater than or equal to. Greater than or equal to is equal to b1. This is first equation, you can say first row, first column, first row, second column, first row, third column, like this. So either it is less than or equal to or greater than, it is means one of these three. Either it is less or greater or exactly equal to. Similarly, say let me write down second equation. a21x1 plus a22x2 plus a23x3. So less than or equal to or greater than or equal to b2. So on. And all these variables, which are sometimes it is also known as decision variable, about which we have to decide, decision variables. These variables are positive. That is, third point is positivity. Positivity. That is, all variables must be positive. There is no sense of negative. So, say x1, x2, so on, greater than or equal to 0. It can be 0, but not less than 0. Less than 0 means minus, then minus has no meaning. For example, you are going for output, you have to produce different types of products, say in furniture, say table, chair and sofas, then it cannot be negative. Similarly, you have to consume your diet conscious, and you want to consume vitamins, protein, alcohol, this, then there is no sense of negativity. So these all xi, for all xi is greater than or equal to 0. So this is the mathematical form of equations. So before going to solve, if I take any example, let me give you particular important hints which you have to remember. Otherwise, it's not easy job to go for it. You have to remember the various, you can say the hints I am giving you. Hints I am giving you. So let me find out the duster. Now, types of simplex problems. Types of simplex problems. There are three types of simplex problem. Number one, pure maximization case. Pure maximization case. Here we define z as objective function, and here z is maximization. Z is to maximize, and this is maybe c1 x1 like this. Subject to, because any objective cannot be easily achieved, so we have to face number of restrictions, number of limitations. Then subject to a1 x1 plus a2 x2 plus so on is less than or equal to b1 a2 x2 plus a2 x1 plus a2 x2 is less than or equal to b2, so on. For all x1 x2 greater than or equal to 0. This is non-negative. This you have to mention. Always be conscious. There is no place of negativity. So when the objective function z is to maximize and all the constraints are less than or equal to type, this is called less than or equal to type. Less than or equal to, then this is called pure maximization case. First of all, you have to see which type of problem you are solving. So this is the first type, z maximum. It will be given in the mathematical form, and equations are less than, all are less than equal to type, then it is called pure maximization. And for to solve this problem, we require, for this, to solve this problem, we require the variables. Then there are three types of variables which we use here. Number one, slack variable. Number two, surplus variable, and number three, artificial variable. But when the problem is of pure maximization, we use slack variable. When the problem is of maximization, then we use slack variables. What are slack variables? Slack variables are basic variables which are added into the objective function with the zero coefficient and into the constraint with the one coefficient in such a way that these slack variable forms a unitary matrix. This we will think and remember how to add slack variables. Say slack variables are S1, S2, say 2 equations and 2 variables, 3 equations and 3 variables. Very clear. Then these variables are basic variables. They are also known as basic variables. And slack variables are considered when the problem is of pure maximization, objective function is maximized and equations are less than or equal to type. Then slack variables are used as basic variables, and basic variables are added into the objective function with zero coefficient, say 0s1, 0s2, and into the constraints with 0s1 with s1 plus 0s2 plus in the second equation 0s1 plus s2. So in such a way that they form a unitary matrix. Now second form is pure minimization problem. Pure minimization problem. The pure minimization problem is that the objective function z is the objective function, is minimization. Objective function z is of minimization. C1 x1 plus C2 x2 plus C3 x3, so on. C's are the coefficients. What are the C's? C are the coefficients of the variable. C1 is the coefficient of x1, C2 is the coefficient of x2, C3 is the coefficient of x3. Subject to your equations say greater than or equal to b1, where b1 is the solution variables, decision variables. A21 x1 plus A22 x2 plus A23 x3 is greater than or equal to b2, so on. Equations can be 2, 3, 4, but for equations more than 3 there will be computational problem. So generally it is numerically the equations are 3. Then this is now the equation where for all x1, x2 greater than or equal to 0, so on. When the objective function is minimization, that is you want to minimize your cost, time, distance, and your restrictions, your constraints, you can say conditions, all are greater than or equal to 0, then it is known as pure minimization. So first of all, if z is maximization and all constraints are less than, then we have checked slack variables will be used. But if it is minimization and all constraints are greater than or equal to type, this is greater than or equal to type, all equations are greater than or equal to then we use two types of variable. One is surplus variable and second is artificial variables. Surplus variables are S1, S2, negative. These are negative S1, S2, so on, whatever. And this is artificial, means dummy. These are A1, A2, like so on. It means if the equations are greater than or equal to type, then we will use surplus variable as well as artificial variable. Because surplus variables are negative, so there is no sense of using negative. Basic variable cannot be used as taken as negative variable. You can say surplus variables are not basic variables. Why? Because these are negative variables. These are added with 0 coefficient in the objective function. Please remember, if the equation is greater than or equal to type, then surplus variable are added into the objective function with 0 coefficient, say 0 S1, 0 S2, and subtracted into the equations minus S1, minus S2, S1 first equation, S2 second equation, and these are subtracted. Because in order to nullify the negativity, we take artificial variable. Artificial variables are used along with the surplus variable. So artificial variables are added into the objective function with plus m added into the plus m. This is plus ma1 plus ma2 and added into the constraints with one coefficient, positive 1. One coefficient means positive 1. So this m is very large number. This is a simple English word, but it is very large number. Very large number. Try to understand again. If the equation is greater than or equal to type, then we are to use surplus variable. Surplus variable are not basic variable. They are negative variables which we will subtract into the equations. S1 from first equation, S2 from second equation, and added into the objective function with zero coefficient. And we use m. M is very large number. We use m and we add artificial variable into the objective function with m coefficient. M is very large number. And ma2 in the objective function. And these artificial variables are also added into the equations, into the constraints to convert the inequality into equality. So whenever we add, these inequalities will be converted into equalities. So this is the point to note. And one thing more, let me clarify. So equation, or you can say inequalities, three types: less than or equal to, greater than or equal to, and third is exactly equal to, because your constraints can be less than or equal to, greater than or equal to, or exactly equal to. This means exactly equal to. If it is less than, slack variable. It is greater than surplus variable plus artificial variable. And if it is exact, only artificial variable. So this point is very important, please. Please note, if the equation or the constraint is greater than or equal to type, then surplus and artificial both will come together. When the equation is greater than or equal to type, then surplus are negative. So surplus are added into the equation objective function with zero coefficient. And say, let me show it. Say 0s1, say 1, then ma1, because a1 is artificial variable. But if the equation is exactly equal to, neither less than nor greater than, exactly equal to, then only artificial variables are used. How the artificial variables are used? Adding artificial variable with m coefficient into the vector function and e coefficient into the equation. When you use the variable into the equation, then it is 1 with coefficient 1. When we use the variable in the objective function, it is 0 or m Now second more important point is, here if the maximization case, for example z is maximum and the equation is this, then this plus m will be converted into minus m. Means if the objective function is maximization, then this artificial variable, the coefficient will be minus m when the equation is greater than is simply equal to type. So these are the two, actually basically there are 3-4 types of simplex method equations. These two are pure maximization, pure maximization. This you have to judge which type of problem is this. Now third point is mixed problem. Third is mixed problem. Mixed LPP problem. So when we say mixed, not pure you have to call means maximization less than or equal to type. Pure minimization all greater than or equal to type. But here mixed, z is say maximization. Z is maximization, first type. Z is maximization and subject to it is equation is greater than or equal to, less than or equal to, or equal to. B point, Z is minimization and subject to greater than or equal to, less than or equal to, or equal to. Equations are mixed. All the 3 types or 2 types are given. Equations are mixed, but here either it is z maximum or minimum. This is the point to be noted. If z is maximum, in case of about variables, z can be either maximum or minimum. That is no other option. So either it will be maximum or minimum. So stick to your problem whether it is of maximization or minimization. If the constraint is greater than or equal to, then you will use only slack variable. And if the equation is less than or equal to, if the equation is then slack variables. If the equation is greater than or equal to, then surplus and artificial variable. Surplus and artificial variable will come together, and if it is third type, only artificial variable. This you have to remember, you have to commit to your memory, otherwise you will be wrong in as formulation of your problem. Once your problem is formulated, then again it's a mathematical procedure that we will see when we will take the examples. So now if z is maximum and you are introducing this artificial variable, the coefficient will be minus m. And if z is minimum, then In case of greater than or equal to type, m is positive. It's not that easy. You have to remember. You have to keep these things in your mind. Only then you can solve the numericals. Let me tell you. I am repeating it again and again for your benefit, so that you may not forget. You have to remember. You have to commit to your memories. Only two types of projective can be there, Z minimum or Z maximum. That is there. But constraints can be of three types: less than or equal to, greater than or equal to, or exactly equal to. If the equation is less than or equal to type, use slack variable. If the equation is greater than or equal to type, then use surplus variable as well as artificial variable. And if the equation is of exactly equal to, then use only artificial variable, no slack variable. Secondly, if your objective function is maximum, then your m will be minus in the objective function. M will be minus in the objective function. And if your z is minimum, then your m will be plus in the objective function. And what about slack variable? It will be 0 in the objective function, 1 in the equation. What will be surplus? 0 in the objective function, minus in the equation, along with artificial variable with plus m if minimization in the objective function, and 1 into the constraints. These things, if you will remember, only then you can solve the numericals. So I will be taking up 4 numericals. One is pure maximization, second pure minimization, third 2 mixed. One is z maximum mixed constraints, z minimum mixed constraints. Sometimes like this also. That say z is maximization, but all constraints are instead of less than, greater than. Again, it is a mixed problem. Listen again. For example, in minimization, we have said that z is minimization and all constraints are greater than. Z is minimum but all constraints are less than. Again, it's a mixed problem, because different steps we have to remember again while solving these problems.